Okay, we're going to look at reflections on the coordinate plane. We're going to look at how to perform them using matrix multiplication. So we know that for reflections over the x-axis, we know the coordinate rule is your xy becomes, you notice here, same x, opposite y. So x comma negative y. So if I'm going to take a transformation matrix. In fact, I'm going to even call it a reflection matrix. I'm looking for a matrix that I can multiply to our pre-image matrix. And that's going to essentially do this for all the x and the y's. So the top row is the x coordinates, -2, 1, 3. The bottom row is the y's, 1, 4, 2. And when I multiply these two, I'm going to use kind of the same idea I did before. So if I rewrite this, here's my matrix. Here's the -2, 1, 3, 1, 4, 2. So then my image matrix is going to look like this. So I'm going to have the top row. I need this to have here, 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 here. I need an x and a y for A prime, B prime, and C prime. So I need all those spots. So that tells me here, I need this to have 2 rows in it, because 2 rows here, and I need it to have 2 entries in each row because I have 2 entries in each column. So now what I want in this spot right here, I already know what I want. I want the same x value. So I want -2 to show up right here. So what numbers do I want to put here so that when I take the first times the first and the second times the second, I'll just end up with, and then adding those two, I'll just end up with -2. Well, if I put a 1 here, I'll take first times the first. That'll give me a -2. But I don't want to add anything to that. Adding anything to that would knock me off -2. So if I put a 0 here, now 1 times -2 would give me my -2, and 0 times 1 would be 0, and -2 plus 0 keeps me at my -2. So I need a 1 and a 0. Now let's just check. This should give me 1, right? I don't want to change the x coordinate. So 1 times 1 is 1 plus 0. That works. 1 times 3, 0 times 2, add those together, we get 3. Great. Now for the bottom row, the first thing here times the first thing up here, that's going to multiply, and that's going to be the x coordinate. Well, I don't want the x coordinate, so I'm just going to say 0 there. And then I want the opposite of the y coordinate. So when I do second times second, I want this multiplication to create the opposite of 1. So if I put -1 there, now 0 times -2 is 0, it kills it off, plus -1 times 1 is -1. There we go. Now let's try it again. 0 times 0 is 0, or 0 times 1 is 0, plus -4. 0 times 3 is 0, and then -1 times 2 is -2. So here's our A prime, B prime, C prime matrix. So this matrix right here, whenever now, it always has to be multiplied on the left-hand side. 1, 0. It's got to be your left-hand multiplier. And it doesn't matter if you're doing a rectangle, no matter how many points the shape has, you can reflect them all by making a matrix out of the pre-image, and then multiplying on the left-hand side by this 1, 0, 0, -1 matrix in that situation. All right, so Now let's look at the next one. This is reflection over the y-axis. This is going to need a new matrix. But if you think about it, we can go through this one a little bit faster now. So I'm going to have my x coordinates over there are going to be 1, 5, 4. Y coordinates are 3, 2, -1. That's my pre-image. And now what do I want to happen here? I want the x to turn negative, the opposite of x, and the same y. So when I put I already know that if I put a 1, 0 there, it keeps the top row the same. Well, I don't want the top row the same. I want opposite of the top row. So I'm going to put a negative there. And then if I put 0, 1 there, we know it keeps the bottom row. And this time I don't want the bottom row to go opposite, so I just put a positive 1 there. So right there, the negatives with the x, the 1s with the y, and we're set to go. So this is reflection over the x-axis. The y-axis. Okay, reflection over the y-axis. And there we are. So we want to keep the y. All right, move over. Now over the line y equals x. So we got to remember, this is x, y, going to become y, x. That's the coordinate rule on the reflection over y equals x. That was in a previous video. So here's my reflection matrix times, let's do these. The a values are 4, 5, or the x values are 4, 5, and -1. The y values are -2, 5, and 3. Just like that. And then over here, now, this one, I'm going to rewrite it again, kind of like we did before. So I'm going to grab this, I'm going to slide it down. And here's the matrix that I'm going to make. The matrix is going to have, I need the matrix to look like this because it needs to have an x and a y for every point. And again, I'm going to have 2 rows in my matrix. I'm going to have 3 columns in my matrix. And what I want this spot to be is I want this spot to be the y coordinate. Well, I know that if I put a 1, 0 there, that'll give me the x coordinate because 1 times the x and 0 times the y. But if I reverse those numbers, 0, 1, that'll kill off the x and just give me the y. So this becomes -2 because it's 0 plus -2. So that'll work across the top row. I think that's going to work. Now in the bottom row, I want really the top number to get down to the bottom row. So I want to keep the top number. So I'm going to put a 1 there because that's the first thing in the column. I want to keep that, but I don't want the second thing in the column. So I'm going to put a 0 there. So that's going to give me a 4 times 1 is 4. 0 times -2 is 0. So this is 4, this is 5, and this is going to be -1. Why did I put a 1 there? Sorry. Go back to this. 0 times -1 is 0. 1 times 3 is 3. That should be a 3 there. There we go. So there is our A prime, B prime, and C prime matrix. This right here is going to be the matrix we're going to use all the time for reflections over y equals x. Okay. Then the last one that we have to do is the reflection over the line y equals -x. And we showed before what that is that's going to be xy becomes -y, or opposite y, opposite x. So what's my multiplier that I'm going to need for that? And again, remember, all these multipliers, all these reflection matrices are always multiplied on the left-hand side. If you multiply on the right-hand side, they're not going to work for you. So going across my numbers again, 4, 5, -1, -2, 5, 3. So now I want them to switch spots. So to get them to switch spots, if I remember right, kill off the top, keep the bottom, keep the top, kill off the bottom. But now not only do I want to keep the top, I want to take its opposite. And I want, sorry, keep the bottom, I want to take its opposite. Not only do I want to keep the bottom or keep the top, I want to take its opposite. So that's the reflection matrix right there. Okay. So let's just see kind of what they would want us to do. If we said, write a matrix equation that reflects triangle ABC, where A is 0, 2, B is 5, 3, and C is 4, 9, over the y-axis. All right, so I know it's going to be reflection matrix times my pre-image. So the pre-image is going to be 0, 5, 4, those are the x-coordinates, 2, 3, 9, here's the y-coordinates. And now I want it over the line, over the y-axis. So that means that I want x, y. Think about what that does first. I want x, y to become, over the y-axis, the y stays the same and the x flips. Okay, so if I want the y to stay the same, that means I want 0, 1 in my bottom row. And I want my x to switch, to go opposite. I want -1, 0. So remember, a 1 in the first position and a 2 in the second position, keep the element in the top row, but now I want a -1. And then I'm going to say, what does that become? And I'm going to probably just use my rule over here. I could go through and matrix multiply here, but I think I just know that this is going to be 0, -5, -4, and 2, 3, 9. So we just did a matrix equation that reflects A, B, C, and turns them into A prime, B prime, C prime. All right, so there's reflection with matrices.